Integrity Houston with some stowage location information and also a note for crew exercise.
Go ahead.
All right, first off, specifically for Reid and a little bit of an impact for Victor, we'd ask Reid to not start exercise until after 2200 MET. This will allow us to complete our op-nav maneuvering and reposition the saws after that. The impact will also be to slide Victor's exercise to the right, but we now have some gray space for that to move into. Now copy.
We copy.
All right, Christina, for you, your question about Velcros and straps, their location will be in bag 16, yellow label, inside 2 Ziplocs, and the inner Ziploc bag will say Velcro and straps. Velcro and wrap.
Copy, thank you.
All right, and finally...
the magic word was wrap. Thank you.
No problem. Finally, to make room in Bravo 1 for the trash bags, we'll have you remove Wiseman's Bob 3 from Bravo 1, and that can be cabin deployed. You'll need to pull out some Nat Geo hardware and possibly some bags from Bag 1 to make room, and they can just go into the Bravo 1 location. Both you and Jeremy have a Bob in Bag 1, and that can either go into F locker, Foxtrot, or be cabin deployed. And then once Bag 1 is full of trash, it is good for return.
Okay, you mentioned restowing in Foxtrot locker. There are several of those. Are you just saying anywhere we find room?
Good words, anywhere you find room.
Copy. And are you keeping the packing plan updated and uplinking new ones? If so, we can be very diligent about letting you know where all these things go.
Copy, Christina, and yes, we update it every night, so the more you tell us, the more accurate we can make that. Thanks.
Sounds great. Thanks, Wilco.
This is Artemis Mission Control, 1 day, 21 hours, 13 minutes mission elapsed time into the Artemis II mission, the first flight of humans aboard Orion. We're continuing to get communications from the crew while on this channel, and if you switch to our other channel on NASA YouTube, you can find today's press conference with NASA and mission management. Here on the ground, the teams are working with the crew's timeline. They are also entering the optical navigation processes and therefore shifting the crew's exercise a little bit today. Crew reported they were fine with that, especially because we have canceled the OTC-1 burn today. That's the outbound trajectory correction 1 burn. This was going to be an 8-second burn, very small, and it was determined it really isn't needed because the translunar injection burn was so accurate yesterday that we do not need an outbound trajectory correction.
Times. Thank you so much. My question, Howard, what specific things have exceeded your expectations in terms of the Orion spacecraft?
Wow, that's interesting. I would say that, just how happy and how well trained the crew is and our teams are to just work through just minor issues that we've had. To me, it's not so much an exceedance of expectation. I expect that, but just to see it in play, just to see how well that's working out. And of course, I expect our spacecraft to perform, but you never know. This is why we have a flight test, and it makes me very happy to see that although we have some minor issues to deal with, the team operates very well with the crew, both on the ground collectively between our mission evaluation room, our flight control team, and with the crew together, working together. And of course, the spacecraft is responding in a way that, of course, we knew about from Artemis I. Every spacecraft is different, but the process is the same, the rigorous testing that we do and the analysis we do. And so I would say that it's always good to beat expectations.
Richard Two of the Post newspaper. A question for Judd. Talking a little bit like a different aspect of this, so that with the MCC, can you talk about so many moving parts make this mission successful coming out of that department? What's the tone and the consensus of the controllers, the directors, as they see this mission transpire, and what are they thinking as far as how things are going so far in the mission?
So my sense is that there's a lot of people that are very excited, right? And excited not only for the overall general, objective that we're going back to the moon, but also just from, there's a lot of time that people have invested in training for this mission, developing the mission, being able to work well with all of the teams together, and to see that come together. I think there's a lot of excitement there, and it shows.
That question, just curious, the technology's changed so much in mission control from the Apollo days to Artemis. Is there anything that you all have learned during this mission? Have you made any changes in mission control? We see the astronauts are making changes on the fly. I'm just curious to know if any changes are being made in mission control as well.
Yeah, I mean, I think you hear it in all of the funnies we see with sensors, the way they behave, the way the systems behave. That means that we are all reacting to that, and we are developing on the fly different ways than we originally thought how we would operate the vehicle. And so that is always an iterative process, right? And I think you're seeing demonstration of that in real time, and that we're iterating on not only learning about the vehicle, but also how to iteratively operate the vehicle as well.
Okay, we'll take another question right here in the room.
Yeah, hi, Beverly Casillas for Space Scout. Thanks again for doing this. Two quick questions. The first one, so we heard that the optical communications demo is already being used to downlink some imagery from the spacecraft. It sounds like that happened overnight. Are there any plans to potentially do any transmission of live video during the mission? And is that something we would get to see, if so? And then a second question, because it sounds like Orion's maneuvering has been really precise during the mission so far, what are you hoping to learn during this mission about guidance and navigation and PNT in the lunar environment? And is there anything that you're kind of already learning about that process? Thanks.
So I'll take the first part for optical comm. The way the trajectory is set up, unfortunately, the only passes that we have with Goldstone are when the crew is asleep. And so anything that we have downlinked would be just, video that you're already kind of seeing, higher resolution of the spacecraft looking back at either the moon or the Earth. And so for that purposes, we're really going to just use it for high-res video downlink. And then your second question.
I think I'll take the.
Yeah, why don't you take that? Yeah.
Can you repeat your second question? I think you said something. Correct my ears. Guidance, navigation, control. So. Yeah. Can you
yes.
repeat that, please?
Yeah, I was just saying, because we've seen how precise the kind of trajectory planning has already been with, not needing to do this correction burn. Have you been having any learnings already about navigation and PNT with the Orion spacecraft and like ground systems during this mission? And is there anything at the moon that you're also hoping to kind of learn and experience on that front?
So, we're using very traditional navigation instruments, so star trackers, the inertial measuring units I talked about yesterday. I think those are we expect them to be precise. They're tried and true navigation instruments or sensors that are on a lot of spacecraft across the board. I think one of the things that we may have not talked about a lot is we have a capability on Orion to navigate without ground comm. And that's the optical comm system.
Go ahead, Integrity.
And, or I'm sorry, optical navigation system. And that's a camera-based system that gives you a really good enough knowledge, navigation knowledge, to be able to return the crew home and perform the mission. And so that's something that's a new capability that we're very interested in. I know the navigation team is certainly very interested. We did do some testing on Artemis I, and we learned a lot from that. We learned a lot from this because it basically takes pictures and translate that size of the moon or the Earth, depending on which way you're pointed, and gives you navigation knowledge from that. So again, that's a tool that we expect, and of course, as an old controls guy, you know, control systems, ability to have.
But all four of the 3 of 3 bobs are behind the seats under the eclipse wall. I'm going to pause for any clarifications before I continue.
Thanks, Christina. We copy that report. No questions so far.
Okay. The other item removed from bag 1 was 2 Ziplocs of Nat Geo equipment. One Ziploc had the Nat Geo Hero 11 and the Nat Geo GoPro handle. The other Ziploc had several things: 3D mic cable, Nat Geo used SD card bag, Nat Geo recorder SD card bag, Nat Geo camera SD card bag, and Nat Geo arm. Those 2 Ziplocs were moved to Flight Day 1 clothing CTB, the small CTB. Stand by. In locker F Foxtrot 2 in the small CTB, which is Flight Day 1 clothing Peltors, and a purple label.
Thanks, Christina. We copy all.
Thank you. Okay, I have a couple more items when you're ready.
We're ready.
The 2 JSBs that contain the contingency urine stowage bags are stowed under the Eclipse net behind seat 4. One of those bags that was repurposed for water stowage is currently floating above the E locker, E as an echo locker, under seat 1.
We copy all.
flyby. Thank you.
In the time that they are going around the moon to take images, they are actually working now with the science team that has gotten underway, and they are doing preparations and working together to figure out what will be of interest and what they expect to see on flight day 6. And so that coordination continues as guided by our science team.
Okay, we'll go ahead and come back here to the room. If I can get a show of hands, how many more questions we have. Okay, we'll jump right over here. We'll take a few on this side, and then we'll come back over to this side.
Hello, Dan Lenahan from the Naval Postgraduate School. You've talked about this mission being a flight test program and an envelope expansion. And with the importance of the International Space Station, can you maybe talk about how the systems in Orion were originally kind of tested out prior to this mission in order to kind of succeed?
Yeah, I'll start with the Universal Waste Management System, or the toilet. The same toilet was flown on space station. I think the crews there were able to operate it for roughly about 2 weeks, if I remember. And so that was a really good, important test in a relevant environment against our toilet that we would be able to fly to the moon with. So that's one piece. I don't think there's probably smaller equipment, like, for example, the CO2 removal system. The heart of it is these amine beads. They absorb CO2 and then we vent it out. The same technology is on the space station, different way on how they approach it, but very similar in terms of absorbing and desorbing of the CO2 that comes from us humans. And that was also a really good foundation to stand on in our confidence associated with ability to remove CO2.
On our main YouTube channel on NASA's YouTube, we do have our live press conference where mission leadership is addressing the media and answering questions about the status of the mission.
And what we've applied for Orion.
But here we're still continuing to provide any crew communications that we're getting, as well as, obviously, our live commentary throughout the mission. We do expect the press conference to last another approximately 15 minutes.
I understand what it is, but I don't understand how the chips interact with the cell samples, if you could school me on that.
So they haven't done the CPR demo as of yet, or at least as I started the conference. So that's later on today. Avatar.
So we don't have a science representative here with us today, but as best I understand that Avatar is actually analog tissue samples from the crew members, and they have been brought on board, and there's going to be an expectation that they'll be evaluating those samples for how they react to the environment while they are on this mission, including reaction to exposure to radiation as well. And so when it gets back, we'll be very interested to understand what they learned, both from the crew themselves as well as their avatars.
And Jonathan, if you need anything else on that, we can get it to you after the press conference. Thank you.
Thank you.
Robert Coppinger, the British Interplanetary Society's Spaceflight magazine. Do you have any information on the status of the CubeSats that were deployed?
Sure. All 4 CubeSats were successfully deployed on the planned timeline about 5 hours after launch. There has been positive communication with 2 of the CubeSat satellites, the one from Saudi Arabia as well as the one from Argentina. And then in terms of how they're faring, at this point, it would definitely be best to reach out to the payload owners in terms of how they're doing. But they absolutely were deployed as expected.
Okay, we'll take another question over here, and then we'll head back over to the right side of the room.
Hi, Katrina Miller from the New York Times. Any milestones we can expect for the rest of today? What are you 3 focused on for the latter half of day 3?
Sure. As was previously mentioned, we have the CPR demo. We'll have another press conference with the crew. They'll go look at do their med kit evaluations of what they have on board. Also, we have, as far as communications with the Deep Space Network, we're going to test out again the emergency comm mode in a more deliberate fashion. And I believe Jeremy has a press conference with so it's a CSA press conference, and then some more planned medical conferences.
Okay, we'll take our next question from Will. Go ahead.
Hi, Will Robinson Smith with Spaceflight Now. Thank you all for the time today. Question for Howard. It might be a little bit early to ask this, but from the performance you've been seeing in Orion so far,
we're going to stow the second Nat Geo GoPro Max camera in F4 video network bag, if you can track that for us.
Orion spacecraft that will fly Artemis III at this point.
We've got it. Thanks.
Of course. And then the images that we've seen so far for whoever wants to take this so far have come from Reid Wiseman. Don't know if that's just happenstance or, if the other crew members are getting good pictures, but will we see a variety of the photography skills in the days to come? How is that kind of being decided and divvied up at this point? Thanks.
All right, I'll take your first question. I think even walking into this meeting, I think, or this mission, and hearing from you here relative to just the software changes we're talking about are going to be caution warning for sure. The limits that we put on, we're going to learn a lot from this mission. So there's going to be, I call them software. You probably don't think of them as software, but really data values for limits. So those will be changing for sure. We have not seen any issues with our flight software, the actual code itself. Of course, we'll learn a lot more as we go forward the next few days. Hopefully, we'll find nothing. But we'll make some adjustments if we need to for Artemis III. Our software development is still a few months ahead of us in terms of completing it. We've got a lot of the software done already. Of course, we've got a lot of software from Artemis II. From a hardware perspective, there's a lot of learning. These, I would say, minor issues that we've encountered and these isolation valves, et cetera, we're going to go check those out and try to get the root cause. And if we have any things that impact our ability to fly at Artemis III, we will work that.
Hey, Howard, why don't you also touch on the different camera capabilities to include the mobile phone cameras, et cetera?
Yeah, so from an image perspective, before maybe Judd talks about who's going to take pictures, if you might or may not know that we have iPhones on board for the crew members, and they're able, not only the Nikon D5s and the Z9s that we have on board that we preloaded already, they were able to also take some iPhones as well. That's what Lakeisha's referring to. And so they'll get some great images from all those cameras. And I'll let Judd talk about who gets assigned the best pictures. I don't know.
Yeah, I mean, I think it's probably just happenstance that you've seen, Reid's pictures. Every one of them are going to be taking pictures, and I'm sure once we get, are able to downlink all of the pictures, I think you will see a suite of pictures from all of the crew members.
Okay, it looks like we have one more in the room. Do we have? Okay, we'll go ahead and take one from you, and then we'll head back over here. Thanks.
Hello, Kaya Burgess from the Times of London. Moon, is there any plan in the future to try and overcome that for future missions, to try and use kind of satellites at Lagrange points or wherever it might be, so that in future that communication behind the moon will be possible and you will never be out of signal in the future? Obviously, it's been possible for Chinese missions that have landed landers on the far side. Is that something that you will be looking into?
So I'll just mention, as part of the administrator's Ignition initiative, he has talked about all kinds of different capabilities that we are going to try to add in a stepped approach to include capabilities on the surface on the moon, as well as communication capabilities. And relay capabilities will be absolutely a part of that for supporting us in the future.
Okay, we have another question right here. And do we have any additional questions after this one? All right, one last question in the room.
Thank you. Rod Powell at Astro Magazine. Similar question. How long do you expect the blackout to be during the flyby? And given that there's no burn back there, is there any reason to be chewing our pencils? And is there anything to learn from the timing when they come back out and you reacquire signal? Thank you.
So as to your second question, no, physics takes over, and physics will absolutely get us back to the front side of the moon. Let's see, I don't think I have the timing yet on this for how long we're going to be out of comm, but I can get you that.
Is it about 40 minutes?
Yeah, it's around.
Somewhere in that vicinity?
Yes, it is 40 minutes. All right, well, it looks like that's all the questions we have for today. Thank you so much for joining. We'll see all of you back here again tomorrow at 4:15 for our next mission status briefing. As always, you can keep up with all the latest news and events during the Artemis II mission at nasa.gov. Thanks for joining.
Integrity Houston with a status and a timeline delta.
Go ahead, Chris.
All right, we wanted to let you know that we are stepping into our burn cancellation procedure here from the ground. We have attempted to suppress any expected caution and warnings associated with that. Just want to give you a heads up. And then we'll let you know when we have a new active burn plan. The other piece is we'd like you to give us a call prior to the CPR demo. Consider that a hard scheduled activity for now so that we can position the SAW. How copy?
Copy all, and let me know when you're ready for me to start exercise.
All right, Reid, I will let you know. Integrity with a mag stowage follow-up for Christina.
Go ahead.
Christina, in your last report, we copied 2 levels of containment for those mags, and we need 3. So our suggestion was to put in a trash bag, if able, or another Ziploc, unless you can correct me and say we've got 3 levels of containment.
We'll go. Thank you.
Thank you much. And Integrity, Reid is go for exercise. We're configured.
Chris, I copy on exercise. I'll be starting in about 5 minutes.
Copy. Sounds good. integrity regarding the enabled caution ORD guide unconverged. Unexpected from us down here, probably related to our recent burn plan uplinking. No crew action. And as we're performing an attitude maneuver, we're going to need Reid to stand down from his exercise until we can get the saws repositioned.
We copy standing down from exercise and copy your words about the caution as well.
Integrity, we are now go for exercise. For your information, both the attitude maneuver and that enabled caution were kicked off because we didn't configure for cycling software during that burn cancellation, but we will get it right for future burn cancellations. In a good attitude now, and saws are safe.
All right, we appreciate that honesty, Chris, and give me about 2 or 3 minutes and we'll be going for exercise.
We copy. And integrity, one small reminder, we would love some pre-exercise AGA readings when able. Thank you.
Okay, Chris, we already turned it on more than 5 minutes ago. CO2 is 1.5, O2 is 20.0. Temperature is 73.2, and our pressure is 14.3.
Thank you, Jeremy. We like those numbers.
integrity for ECG.
Go ahead, integrity.
Hey, Chris. When I'm attempting to get a good electrode connection to the ECG, it never indicates a good connection. I verify that I'm doing the holding per step 2.1 in the procedure, and I have a good connection. I just never get past the screen that says touch the electrodes to start recording. I've tried it multiple times. One idea I have is that maybe it has to do the low state of charge of the phone. It is only at 14%, so perhaps it's gone into a power savings mode that's preventing some of the Bluetooth connection features. Other than that, I don't have anything I can offer, but over to you for any ideas.
Hey, Christina. Thanks for that. Good reporting. One thing you might try is plugging in the medical tablet to increase its charge and see if you see green dots on the display.
Okay, and to clarify, do you mean plug it into charging off of our USB charger or plugging it into the PCD?
That'd be plugging into the USB charger.
That can work.
integrity for exercise.
Go ahead, Reid.
Hey, Chris, it's Victor. I'm getting started late, but I would like to, if it's okay with y'all, to exercise right until midday meal.
My apologies, Victor. We're checking. Integrity, Victor, you can go exercise all the way up to midday meal.
Copy, I'm getting started. Thank you.
No problem.
Houston, integrity on 1 for HHP.
We're with you.
Hey, Chris, Victor's about to start exercise, but he's encouraging video downlink, so if you want to come on the HHP, I'll start the stream.
Thanks, Reid. We would absolutely love that, and thanks, Victor, for his willingness to let that happen. Reid, I do have an additional comment for you and the rest of the crew about a possible opportunistic photography and science opportunity over your midday meal. There's a period where we're going to have Earth viewing followed by moon viewing. You can reference the Orion attitude band in Optimus. It's kind of right in the center of your midday meal. And if you'd like to do any photography, we're recommending deploying and using the camera shroud over window 2 to reduce glare.
Okay, we love those little opportunities. Thanks for sharing them. Keep them coming.
Houston, integrity for ECG.
Go ahead, Christina. How's the troubleshooting going?
Hey, Chris. We are connected and charging on the little tablet. However, no joy getting a signal on myself nor Jeremy. Two things I can think of to try. One would be to let it continue to charge. It did just reach 20%. I checked, and it does not seem to be in any battery saver mode. In fact, it says battery saver unavailable. I also checked the Bluetooth devices. The ECG is showing up as a device. However, it is giving me the option to connect in the Bluetooth area, and nothing happens when I do it. It does seem to be finding the device when I'm in the app. So the other thought I could try would be to forget and reconnect the device.
Christina, that is an excellent idea. Good troubleshooting so far. Yes, we definitely want you to try the forget the device and then try and reconnect. And then another piece of data that might be useful for us is whether you see a battery symbol at the top of the medical tablet right-hand corner.
Do you mean within the app or just in the screens of the tablet?
Good clarification, within the app.
Okay, within the app, when the screen instructing to touch the electrodes to start is up, I do have a battery icon in the upper right. However, it is gray with a question mark inside.
Okay, Christina, thanks. Yeah, that just gives us that confirmation that it's not connected to the ECG. Let's go ahead and continue with that Bluetooth troubleshooting steps for getting and reconnecting.
Houston, integrity for ECG. No joy seeing the device in the list of available devices when I attempt to repair it after doing the Bluetooth forget.
Okay, Christina, unfortunately, we are out of ideas at the moment. We're going to do some more thinking. We really appreciate all of your troubleshooting steps and actions you've taken. Great data for us. But we'll move on from this activity for the day. Thank you.
Copy all. I will keep the medical tablet charging and restow everything. Thanks for the help.
Copy all.
exercise complete. Thank you.
Thanks, Integrity. We copy.
Houston, integrity, AGA readings when ready.
All right, we'll take them.
CO2 1.0, O2 20.1, temperature 75.7, temp pressure 14.2 psi.
Copy all, and we believe we copied CO2 1.0. Just want to confirm.
One decimal zero, 1.0, that's correct.
Okay, thank you.
You're welcome. And a question, do you guys always want these called down, or is a crew note enough?
And our preference is copy all, and we believe we copied CO2 1.0. Just want to confirm.
One decimal zero, 1.0, that's correct.
Okay, thank you.
You're welcome. And a question, do you guys always want these called down, or is a crew note enough?
And our preference is call down. Just helps us keep in sync with you guys real time.
Copy.
With the completion of this block of exercise for today, Glover calling down readings from the AGA, the Anomaly Gas Analyzer. Those readings are requested before and after exercise, so they leave the device on throughout the time period that they are using that flywheel device. This helps teams on the ground monitor what the levels in the cabin are for the various molecules that Glover called out, and those are reported in parts per million. And we have just passed 2 days mission elapsed time. 2 days since the launch of Orion, atop the Space Launch System spacecraft from Kennedy Space Center in Florida, a very smooth ride uphill. We are now 3 days and 19 minutes away from the opening of our lunar flyby, targeted for flight day 6, when the crew will fly around the moon, the first time in over 50 years for humans to do so. This is Artemis Mission Control, 2 days and 14 minutes mission elapsed time for the first flight of humans aboard Orion, and I am joined here by Paul Boehm, Orion Crew Support and Thermal Systems Manager. Thank you for joining us, Paul.
Oh, thank you very much for having me, Leah. Appreciate it.
Yeah, absolutely. Well, tell us a little bit about your role. You just came from the Orion Mission Evaluation Room, is that right?
Yeah, actually, I just did. I was just checking our systems to see how things were going, and I am really pleased. So my role is I manage the hardware related to crew and all the crew systems on the vehicle, the ECLA system, the thermal systems, the suits, the flight crew equipment that are on the vehicle, and so been doing that for almost 14 years now.
Wow, that's impressive. And when we're talking about the ECLA system, that stands for Environmental Control and Life Support System. So what all makes up ECLIS?
ECLIS, yes. The biggest thing everybody thinks about for ECLIS is the life support system, the pressurization system, the air revitalization system that we have, and then the other parts of it that are also part of it is the thermal aspect of it, where we're cooling the air to be able to keep the crew temperature down exactly where they want it to be comfortable in the cabin, and so that is also part of our system as well.
Yeah, we heard them make some calls a couple days ago about being a little chilly, and your team is the one that works on making sure they're comfortable?
Yes, we've been working at the last couple days, trying some adjustments. It's one of the things I will stress with the new vehicle. We are learning every single day that we're flying this vehicle right now, especially with the crew in it. We flew Artemis I, we learned some things about the systems there, but now we have the crew involved, which adds a whole new dynamic to the vehicle, and that is what is really what we're looking at today, and learning how to interact with the crew and adjust things as we need to make the crew comfortable.
Yeah, that's fantastic. And you also work with the food systems a little bit as well. So they're actually getting ready for a midday meal. We've been fortunate enough to have in-cabin views for some of today, and we saw them getting out some of their food. So can you tell us about the food warmer?
Yeah, the food system is, the crew is, a lot of the food that we use is very similar to what they fly in ISS. It's the rehydratable food, and what we use on Orion, we have what we call a food warmer. It's about a little suitcase-sized device, and our biggest challenge is mass and volume on Orion going to the moon. And so we had to reduce the size of a galley. We would love to fly a galley, but we just can't because of the mass and volume challenge. So we have a suitcase that basically the crew inserts their food into the suitcase. It's a warming plate and heats it up to about 155 degrees.
Oh my goodness, that's much warmer than I expected you to say. That's really impressive.
It's what they use for doing the hot drinks, warming up the food that needs to be warmed up so that it tastes better when it's warmer. So they can put about 12 packages in there to be able to heat up those and be able to have some hot food during the flight.
I'm impressed. I used to be a taste tester here, and so I always enjoyed trying the food. I found it to be really good, and so
it is amazing what they can do.
Yes, it really is. So tell us more about the ECLIS system and how it's performed so far now, 3 days in.
Yeah, I'll be honest, I am extremely excited how it's performing right now, because it is actually better than our predictions, which is really great. The carbon dioxide removal system that we are flying for the first time on a human spacecraft, relying on it, this particular system has been outperforming what we thought it was going to do. It's been awesome. So really low levels, and the crew's so far been pretty complimentary of it.
That's incredible news. So you were talking a little bit about, the temperature and how this is the first flight with crew, and so everything you're doing is learning. So what is your team hoping to learn on this mission?
So the biggest thing we're doing, number one right now, as I mentioned earlier, was because it is a flight test and it's the first time we're doing it, we're learning how to tweak things, we have heaters and we have the systems like the CO2 system I mentioned earlier. We're learning how to balance all those things as we work with the crew, because each crew member is different metabolically. We have different met rates that the crews have as they're doing different exercises, like you saw them exercising earlier today, versus when you're doing a meal, you're pretty calm, and therefore you have a very low metabolic rate. So those variables really change how we interact with the crew, with our system. And so that's really what we're learning today, is how our system interacts with the human.
We need a few minutes. We'll call you when it's a good time.
Copy, sounds good. We'll wait for your call.
That call from the crew about performing a wastewater dump, we actually had great views earlier from inside the cabin while they did so. It was fascinating. Talking about, preparing for the future, but we've also had similar hardware on the space station for the past 25 years. So what are some differences in the hardware that we have now on Orion and versus what, we have on the International Space Station?
Yeah, our biggest difference between Orion, because we are a deep space vehicle, you have that very long return, and there's no coming back until when you do that translunar injection burn that we did yesterday. And so it's going to be many days before we can actually get back. So when we designed Orion, we really looked at the ecosystem to try to figure out how can we make it simpler. And then some of the systems that we have, as I mentioned, the CO2 removal system that we have, we needed a regenerable system such that you weren't flying consumables that you had to use up every day and replace. That's a lot of things. I think I calculated one time, it's about 143 basketballs worth of lithium hydroxide canisters we would need to do a 21-day mission with Orion versus our current system, which takes about 16, volume about 16 basketballs to be able to go do that. And so it's a regenerable system. It essentially removes the carbon dioxide from the cabin air, dumps it overboard, and those items are recyclable every time you expose them to vacuum. They regenerate, and now you can expose it back to the cabin air again and remove more CO2. So it's those regenerable type systems. We flew some test examples of this on ISS to see how that went, but this is the first time we're actually flying with this type of system on a human spacecraft and completely relying on it.
Wow, amazing. And we've also heard some calls about the anomaly gas analyzer and taking those readings and the calls down from the crew about what they have gas-wise in the cabin. So how does your team take that data and interpret it?
So the biggest thing we have is certain limits on CO2 levels that we try to maintain without getting too specific, but I will. It's 4 millimeters of mercury is the level that we rely on. And basically we use those AGA measurements to basically bounce against that level that we're at. And so I believe, if I remember correctly, it's about 0.4 millimeters here on the ground that we're normally breathing. And so we try to stay as low as possible with carbon dioxide in the cabin. So, and the readings that we're seeing right now are actually kind of phenomenal for a human spacecraft. So it's great.
Wow, that is great. Well, congratulations to you and your team on a great mission so far, and we will be keeping an eye on everything as we move forward. But Paul, thank you again for joining us here.
Oh, thank you very much for having me. It's been a great flight so far.
Christina, while I've got you and the crew, I have some information regarding a replan for the afternoon. Shouldn't require too much back and forth, but let me know. First is we don't have any other vehicle statuses from what we've already told you. So unless you guys have questions for us,
Houston
we were going to go ahead
Integrity,
and
you are go for
cancel the
Blizzard.
Flight Director Crew Conference. That's in 10 minutes. Copy, go for Blizzard. We also are going to do a little bit of a replan with you guys managing the afternoon post-midday meal. Christina, while I've got you and the crew, I have some information regarding a replan for the afternoon. Shouldn't require too much back and forth, but let me know. First is we don't have any other vehicle statuses from what we've already told you. So unless you guys have questions for us, we were going to go ahead and cancel the Flight Director Crew Conference. That's in 10 minutes. We also are going to do a little bit of a replan with you guys managing the afternoon post-midday meal, basically after the PAO event. We'd like to give you a bit more time for exercise and sliding back that S-band SAT mode DFTO a little bit. And then exercise after that. This means that you'll have to manage some of that pre-lunar flyby cabin config and other activities just amongst yourselves. But this should allow us to get in all exercise and have enough time post-PAO event for that S-band SAT mode DFTO. The DSN EMERCOM DFTO needs to stay where it is because there's some vehicle maneuvers that have to happen with that.
And Chris, if it helps you, Victor and I have both exercised, so he is more than happy to do the S-band sat mode DFTO on time. Hey Chris, let me just make sure. Are you saying we can defer the S-band sat mode DFTO, but do the DSN EMERCOM on time?
To give you. We'd like that S-band sat mode DFTO to slide 30 minutes to the right for some ground config. But then the EMERCOM DFTO will stay where it is.
Okay, that sounds good. And Chris, if it helps you, Victor and I have both exercised, so he is more than happy to do the S-band sat mode DFTO on time. Is done and you're ready for that activity, that would help us out.
Absolutely, will so. Thanks, Reid. Just talking down here with the team to make sure I got the right words to give you. We'd like that S-band sat mode DFTO to slide 30 minutes to the right for some ground config. But then the EMERCOM DFTO will stay where it is. There's, like I mentioned, this good Earth and Moon viewing positions. It's also roughly when you're going to pass close to the
that sounds good. Ike will be ready 30 late for S-band sat mode, but if you could also please give us a heads up when your commanding is done and you're ready for that activity, that would help us out.
Absolutely, will go. The other thing we want to remind you is that in your midday meal, we have about a 1 hour forward DSN LOS. But for most of that, we've got return. Great. And kind of in the middle of your midday meal period, you'll notice there's, like I mentioned, this good Earth and Moon viewing positions. It's also roughly when you're going to pass close to the halfway point between the Earth and the Moon, and you can reference your altitude on the PFD for that midway point.
Yeah, crazy that we're seeing 105,205 miles, and it's still going up pretty quick. Thanks for all that, Chris.
Great. Thank you guys so much. Enjoy your lunch.
Those calls from Capcom, capsule communicator Chris Birch, also a NASA astronaut here in Mission Control Houston, up to the crew aboard Orion, named Integrity. This view of Artemis Mission Control, the Orbit 1 team still on console. The crew was enjoying their midday meal. We do not have fresh foods flying on Artemis II. Orion does not have refrigeration or a late load capability prior to launch that we need for fresh foods. So we have shelf-stable foods aboard Orion and rehydratable foods that the crew is used to, having flown on the International Space Station. As we saw in the earlier video, the Artemis II crew had direct input into the food that they have available during the flight. They were able to sample and rate all of the foods on the menu, and their preferences were balanced with the nutritional requirements needed and what Orion can accommodate. Back with those live views of the Artemis II crew. We just spoke with Paul Boehm, Orion Crew Support and Thermal Systems Manager, telling us a little bit more about the food warmer on Orion. So if the crew needed to heat up any of the foods that they are eating today, they were able to do so with a approximately briefcase-sized food warmer to heat the meals as needed.
Integrity Houston, sorry to interrupt your lunch, but we have a commanding request prior to CPR demo during the forward LOS. Let me know when you're ready. Integrity Houston, sorry to interrupt your lunch, but we have a commanding request prior to CPR demo during the forward LOS. Let me know when you're ready. We would like you to first confirm we are in coast to default 4100, and then please put all 4 saws into safe harbor A, then start the CPR demo. I'll copy.
Go ahead, Chris.
All right, because you'll be starting the CPR demo activity while we're in that LOS, we would like you to first confirm we are in coast to default 4100, and then please put all 4 saws into safe harbor A, then start the CPR demo. I'll copy.
Okay, Chris, before starting CPR demo, we will verify coast to fault 4100, and we will command all 4 saws to safe harbor A.
Good read back. Thanks so much. Integrity courtesy call, not knowing your preference. We did have video of Victor, which we have stopped going out on our PAO stream. Integrity courtesy call, not knowing your preference. We did have video of Victor, which we have stopped going out on our PAO stream. Update our now growing crew preferences sheet. Thank you.
We appreciate that, Chris. We were definitely good with it going out, but we also understand if you want to restrict, no problem either way. Okay.
Copy all. I will update our now growing crew preferences sheet. Thank you.
Back with views aboard Orion as the crew continues their midday meal. NASA astronaut Victor Glover having completed his exercise. Cleaning up in space. Obviously, we do not have showers aboard the Orion spacecraft.
Integrity, toilet will be available throughout the LOS.
This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. Getting a live look inside the Orion spacecraft. They are still...
Integrity, toilet will be available throughout the LOS.
The crew is timelined in their midday meal right now. Obviously, they have mostly finished eating, but the ground teams also let them know they should have some great views of the moon and the Earth outside of their windows, should they choose to take pictures at this time. As we saw earlier, there are also timelined wastewater dumps from Orion, and during that time, the crew is instructed to not use the toilet. So the crew is about to go into an LOS, loss of signal, while they're on the Deep Space Network, and the ground teams here were calling to let them know that there will be no wastewater dumps scheduled during that time, so they'll be able to use the toilet as they need. This view outside the Orion spacecraft, you can see those solar arrays positioning. And a reminder, you can keep up with where Orion is at any time by visiting nasa.gov/track-Artemis. Currently, the spacecraft is 122,500 miles away from Earth and 146,000 miles away from the moon. Up next on the Artemis II cruise timeline today will be the CPR demo. Ground teams have requested that as the crew conducts this demonstration with choking and CPR responses in the cabin, that they configure one of the cameras for recording. They'll be able to use the footage captured for this for future training use. We are 2 days, 1 hour, 3 minutes into the flight of Artemis II, the first flight of crew aboard Orion. Spacecraft now 123,000 miles away from Earth. You're getting a live look inside the capsule as our 4 crew members, Reid Wiseman, Victor Glover, Jeremy Hansen, and Christina Cook, are wrapping up their midday meal, getting the opportunity to take photos out the window of Earth and the Moon. We are in an LOS period, loss of signal from the ground side. This was tracked and communicated to the crew. However, we do receive communications from the crew members. Obviously, we have their live video right now. Inside Orion, you see they have dimmed the cabin lights. They have this option to allow them to get better views outside the window so there aren't any reflections from that lighting onto the windows. Being that we are 123 miles away from Earth and that distance continuing to grow, we are 145,000 miles away from the Moon. And I think I previously said 123 miles from Earth. That's 123,000. So we are getting closer to that halfway point between the Earth and the Moon. We look forward to the opportunity to share some of these pictures that they are taking today, along with everything else during the mission. We did receive some beautiful images this morning from the crew as they departed Earth after the translunar injection burn yesterday. You can follow NASA on social media at NASA or at NASA Artemis to see these pictures as we receive them. This is Artemis Mission Control. Clearly, what you have on your screen is a visualization. We are in a loss of signal with the Artemis II crew and the Orion spacecraft. This was a tracked LOS while we are on the Deep Space Network. We expect to regain communications shortly. In the meantime, the crew using some of their lunch break to photograph Earth and the Moon outside of the cabin windows. This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. Mission elapsed time of 2 days, 1 hour, 26 minutes of the flight of Artemis II. Our crew members aboard have wrapped up their midday meals. They are now moving into the CPR demo. This allows the crew to practice how they would practice CPR should they ever have the need aboard the Orion spacecraft. They will record this for the flight teams here on Earth to analyze and use as future training. You also just saw some movement on the camera. They were moving the solar array wings into the safe harbor position. This is what we do when we expect any movement inside the spacecraft, whether that be exercise or something like this CPR demo. We won't have inside views during the CPR demo.
Houston integrity in the blind. We are in 4100 coast default. 4 arrays are safe. Beginning the CPR demo now.
And if you heard that call from Commander Reid Wiseman, he says in the blind, not knowing whether we can hear them or not because we recently experienced a loss of signal or an LOS. Obviously, we did hear that call from the crew. This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. The crew aboard Orion conducting their CPR demo, learning how they would offer CPR to a crew member in need if the need ever arose on the spacecraft. Of course, this is just a demonstration and it will be used for future training for future flyers. Another consideration when we fly in space are solar eruptions. Between the Apollo 16 and 17 missions, the solar eruptions were a near miss for our lunar explorers. Today, those Apollo-era flares serve as a reminder of the threat of radiation exposure for astronauts in space, as well as technology. So understanding and predicting these solar eruptions is crucial for our safe exploration. We now have data, technology, and resources available that have improved, which enable advancements towards space weather forecasts and astronaut protection. These are all key to NASA's Artemis program to return human astronauts to the moon.
It's August 1972, and Ian Richardson, a future NASA scientist, is watching TV when the BBC announces
the interference is caused by solar activity.
He didn't know it then, but the sun had just erupted in one of the most powerful solar events ever recorded. There was no threat to humans because Earth's magnetic field deflects much of the sun's radiation. But the explosions were so powerful that intense radiation disrupted TV signals and caused radio blackouts. So what if you were outside Earth's magnetic field? On the moon and beyond, astronauts face the risk of extreme radiation exposure. Luckily, the intense radiation in 1972 occurred right between the Apollo 16 and 17 missions, when no astronauts were in their path. As NASA plans missions to go back to the moon and then onto Mars, predicting the sun's activity to protect astronauts from space radiation is one of our biggest priorities.
One of the biggest unknown factors about going to space is the radiation hazard from the sun.
This is Ian today, studying the effects of the sun, also known as the field of heliophysics.
The sun is always emitting radiation like the light we see, but certain energetic particles, like from the August 1972 events, can be far more harmful.
To be able to forecast solar energetic particles, we need to know how the sun energizes them. The sun is made up of electrically charged particles called plasma. As this plasma moves, it builds up energy inside its massive magnetic field. This energy is usually released in two types of explosions. Flares are intense flashes of light. Coronal mass ejections are giant eruptions of solar material.
These solar eruptions send shock waves across the solar system, accelerating particles as they go.
These are solar energetic particles, or SEPs. They consist mainly of protons and possess a lot of energy that can affect satellite measurements and humans.
SEPs can bombard you with a lot of radiation in a short period of time. They can penetrate your skin, damage your DNA, and increase your chances of getting cancer and radiation sickness.
But they don't occur with every solar eruption. Only a small number of flares and coronal mass ejections create SEPs.
So we're trying to predict when SEPs form and how they travel through space.
At NASA's Goddard Space Flight Center, the Community Coordinated Modeling Center, or CCMC, is dedicated to testing prediction models. Working with global partners, they use data from NASA satellites at different vantage points and models to figure out how solar explosions behave, including how shock waves energize SEPs. And as we get better at predicting, we get more time to prepare.
Preparation for an SEP event, of which you may know that is already coming and perhaps the magnitude as well, the technique that you would want to use is to put as much mass between you and the source.
On the surface of the moon or Mars, astronauts can go underground or build shelter with local materials. But in transit, astronauts can only be protected with what's on the spacecraft.
Which means that you might have elements on a spacecraft that have multiple purposes.
NASA's space radiation specialists are testing different ways to do this. One strategy they tested on the Orion spacecraft involves crew members barricading themselves with as much mass as possible in the center of the spacecraft. Other Other possible techniques in development include vests that add mass and electrically charged surfaces that deflect particles.
In terms of radiation protection and radiation mitigation, the factor of time is extraordinarily important.
The Sun has a natural 11-year cycle that transitions through low and high activity, which is indicated by the number of sunspots on the surface. More sunspots mean more eruptions, resulting in a higher risk for SEPs. But during this increased solar activity, the Sun's magnetic field strengthens, enhancing its shield against another important source of radiation, galactic cosmic rays. These are charged particles traveling at nearly the speed of light that are thought to come from supernova explosions from within our galaxy and possibly further out in the universe. If solar energetic particles are intense sporadic storms, then galactic cosmic rays are a constant drizzle. Galactic cosmic rays are more sparse, but also much more energetic. They include heavier elements that can penetrate through vast amounts of materials. Understanding the rate of galactic cosmic rays helps us determine how much time astronauts can spend in space safely. To date, humans have only been on the lunar surface for a cumulative total of about 12 days. A trip to Mars will take 6 to 10 months each way. That means even more radiation exposure, and so NASA is doing work to prepare for that.
The moon is going to be a test bed for us in order to be able to prepare for Mars. The more that we understand the impact and the duration of radiation on the moon, the more we can extrapolate that to the length of time that we will be spending in transit and on the surface of Mars.
You're looking at a live view of the outside of the Orion spacecraft. Specifically in this frame, you can see the European Service Module and the Orbital Maneuvering Service engine. And in the video we just watched about deep space radiation, you saw some team members demonstrating how they could use cargo transfer bags to help protect a crew from radiation exposure. That is something that this crew will test out as well. On Flight Day 8, they have a radiation shelter demo timeline. During that time, the crew will build a makeshift radiation shelter within the cabin and prepare the lockers on the spacecraft for ingress. Of course, this is just a demonstration and practice in case it were to be needed for a future mission. Orion is currently traveling 3,246 miles per hour, 125,130 miles from Earth, and 144,220 miles away from the Moon. If you're just tuning in with us today, we were expecting to have the outbound trajectory correction burn this afternoon. However, that burn was canceled as it was deemed unnecessary following such a precise translunar injection burn yesterday. Teams confirmed we are on the proper trajectory to send us around the moon and bring the crew home on Flight Day 10 with a splashdown in the Pacific Ocean. So they were able to cancel the outbound trajectory correction burn. And according to Christina Cook, the crew was able to enjoy a snow day. This is Artemis Mission Control at NASA's Johnson Space Center in Houston, Texas. The Orbit 1 team is currently on console, but you'll see a lot of activity happening in the room as the Orbit 2 team comes in to begin at their shift. Of course, Mission Control is staffed 24/7 while in flight with Orion. And just down the hall, we have the International Space Station Flight Control Room, which has been staffed 24/7 now for over 25 years. Integrity Houston, comm check, back with you on DSN.
We have you loud and clear.
Fantastic.
And Houston, we are complete with CPR demo if you want to get everything back to normal after that.
We copy. Thanks, Christina.
This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. We have reestablished communications with the crew after an expected loss of communication through the Deep Space Network. We are now back in full communication with them. The crew reported they just completed their CPR demo. Again, just a practice of how they would execute CPR in the Orion cabin if need be. They were able to film this and will share it with the ground after their flight. And this view on your screen coming from a camera mounted on one of Orion's 4 solar arrays. Each solar array wing has its own camera, and this one is currently pointed back to see all of us on Earth. Wave hello, you look great today.
And Houston, we're just curious about toilet. Is it off, hands off right now?
Integrity, toilet is go for use.
Okay, integrity copies.
This live view inside Orion of the Artemis II crew.
Integrity feedback on your camera position. For your information, the top third of the flags is not visible. And now where you're placing the flags, I can see all of them. On the bottom part of the image, I can see about midway on Christina's calves, and I can see Victor's head and the camera to the in the right side of the field of view from the perspective of this camera. Copy, thumbs. Looks great. Christina is well centered in the frame.